Hello students, in this video I'm going to cover question number 9, and this question and the things which I'm going to solve here, guys, I can tell you this will help you to solve at least 3 to 4 questions in your multiple choice and one 10 marks question in your writing based question. So just focus on this part. So there are few things which you need to focus to find electric field. To find electric field, I'm giving you some situations. Case 1, the best or simplest case, let's say single charge. If you have a case of single charge, let's say this is a positive charge, so what is the electric field? We know this is the simplest case, k q over r square. Let's say this is the point and this is the distance r, this is your k q. Fine. Okay, next case, let's say if you have a wire, case number 2, wire. If you have a case of wire, long wire or infinite wire, long wire, let's say this is the wire and it has a charge q, uniformly charged q, and surface charge density, linear charge density lambda, which is equals to charge by length. In this case, you need to understand the equation. E is equals to 2 times k lambda over r. Lambda over r. R is the distance. Let's say you are finding somewhere here. So this distance is your r. Fine. Okay. Case number 3. This is something very, very interesting, and this will help you to solve the question in the capacitors also. So it is the case of sheets. So there are the two parts. Let's say this is the sheet. Okay, how many faces? This is called phase 1 and this is called phase 2. Do you understand? Okay. If you want to solve electric field, only one phase, you have to solve for only one phase. In that, E is equals to sigma by 2 epsilon naught. Sigma by 2 epsilon naught. Or if you have to solve for both the phases, okay, in that case, E is equals to sigma by epsilon naught. This is for two phases. Remember this thing. I'll give you a hint here. Let's say if you have a question like this, this is called parallel plate. Even in terms of capacitor also you will get this same word, parallel plate. So one phase this side, phase 1, one phase this side, phase 2. So if you want to find the total value, so the total value is E is equals to E1 plus E2. In that case, your net value is sigma by epsilon naught. Remember this thing. This is very, very important. Okay, after that, you have the two more things. You have a conducting shell and you have the non-conducting shell. So how you are going to solve that and about the graphs. Okay. So I need to add a page for you. Okay guys, now just focus here. This is something very interesting. Let's say this is called conducting and it is also called shell, empty from inside. And here you have the non-conducting or filled from the inside. Okay, let's say there are the question. This is the shell and this is the charge. Okay, we have the three conditions. This is the condition 1. You can say R1. We have this condition on the surface R2. We have condition here R3. And this is something you can say this is the radius. Okay, let's say there are the different conditions. So case number 1, when R1 is less than radius, Where is the body? Inside the shell. Where is the second body? Let's say here is charge q1, here is your charge q2, where you need to find the effect. Okay, or not the charge, but the you need to find the effect here. So what is the answer? Electric field is 0, because inside empty surface electric field is always 0. Case number 2, when R2 is equals to capital R, means on the surface. Where you are looking for? Here on the surface. Can I say R2 is equals to radius? In that case, E is equals to KQ over R2 square or KQ over radius square. Fine. Third case, outside, when R3 is greater than capital R, outside the body. Outside the body, okay, then solve it. E is equals to KQ over R3 square. Do you understand? Sure. Okay, now make a graph for this. If you make a graph for this, capital R is less than capital R. Let's say this is your radius. R equals to R2 and here is R3. Okay. So when you have less than value, so what is the answer? Answer is 0. This is your graph 0. Electric field is 0. Understand? Okay. Whenever on the surface you have, this is called maximum value. Maximum value. And after that, whenever the distance starts increasing, it starts decreasing. So E proportional to 1 over R square. Fine. Okay, these are the three things. Okay, then for here also, here is also the same case. This is filled. So you have, let's say this is your R1, this is your R2, this is your R3 outside. Okay, and this is your radius R. So in this, only one case is different, inside. Case number 1, when it is inside, when R is less than, when R1 is less than radius, in that case, E is equals to E is equals to rho R1, you can say, divided by 3 epsilon naught. And these are the equations given in your exam also, but you need to think that which case you are solving. This is called inside. And case 2 and 3 both are same, like this one. So for E2 you can say KQ over capital R square. E3 you can say KQ over R3 square. Fine. If you make the diagram or if you make the graph, when R1 is less than capital R, and R3 is greater than capital R. So in this, first is directly proportional and then like this. So here E proportional to 1 over R square, not the capital one, it should be smaller one. Here is the maximum, E max, and here E is directly proportional to R. Clear, guys? So you understand all the cases. If there is a single or point charge, wire, sheet, one phase, two phase, conducting shell, non-conducting shell. Okay, let's start the question. Question. Consider a sphere. Okay, not the shell, it's a sphere. So it means it is filled of radius R. Okay, whenever the question will come, draw the diagram. Then it will become easier for you to solve and understand the situation. Radius is capital R. with a charge uniformly distributed. Okay, we have a charge q uniformly distributed throughout the volume. You know na, volume rho is equals to q by v of the sphere. What is the magnitude of electric field at point 2r? So where is the point? Tell me. It is outside. That is your 2r. Understand? So we can solve it easily. E is equals to k q over r3 square. Yes or no? This is your r3. So you can place the value k q over 2r whole square, which is equals to k q over 4r square. Fine. Understand? Like this, you need to solve the question, huh? Okay, now something interesting. Two, this is the major word, huh? Two. So you need to focus how many sheets, two infinite non-conducting plates are parallel to each other with a distance. Okay, distance is given between them as shown in the figure. Each plate carries a uniform charge distribution. Sigma is given. Sigma 1 is equals to sigma 2, which is 4.5 micro 10 raised to power negative 6 coulomb per meter square. What is the magnitude of electric field? What is the magnitude of electric field at point P? At point P. So guys, I told you at point P, first is applying, second is applying. Yes or no? Yes or no? Just try to understand. This is the first sheet, this is the second sheet, P is here. So first sheet is applying, second sheet is applying. It means E is equals to E1 plus E2. Yes or no? And both have the same charge. So can I say E1 plus E2 is equals to E net? Okay, so because of 1 sigma 1 over 2 epsilon naught, E2 is over sigma 2 over 2 epsilon naught. We know both are same. So can I say E net is equals to E1 plus E2 sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which is equals to sigma by epsilon naught. Place the value 4.5 times 10 raised to power negative 6 over epsilon naught is 8.85 times 10 raised to power negative 12. So once you solve this, you will get 5.08 times 10 raised to power 5 Newton per coulomb. Clear? Fine. Okay, so the answer is D. Okay. Next case. A solid. Solid means filled. Okay, just remember this thing. Non-conducting sphere, radius A. Okay, I told you first of all, whenever the questions will come, draw. Your radius is A. Okay, has a total charge capital Q and a uniform charge distribution. Using Gauss law, determine the electric field vector in a region R is less than A. Let's say this is your body and this is your R1, which is equals to R. And when it is outside, let's say this is your R3, which is equals to R. So case 1, when R is less than A, it means inside the sphere. Yes or no? Okay, so you can solve it easily. We know the equation E is equals to rho A divided by 3 epsilon naught. Clear? Case 2, outside. Okay, so in case of outside, what we have E is equals to rho, not the A rho, outside is K Q over R square. Clear guys? Fine. Like this, you can solve your question in a very easy way. Okay, next question. There is an electric field of magnitude E is given 150 Newton per coulomb. directed downward, okay, near the surface of earth. What is the net electric charge? What we are looking for? Charge. And the word is called earth. Can I say sphere? Yes or no? Okay. So what we are looking, near the surface, near the surface. It means, let's say this is the earth. So near the surface means outside the shell or outside the sphere. So in both the cases we have the equation E is equals to K Q over R, not the capital small r square. Yes or no? Sure? Okay. But what we need to understand, you can treat earth as spherical conducting and radius. So we can take this nearby, because if something is near to earth, if r is approximate equals to capital R, radius of earth, then we can use the same value, 6371 kilometer, which is equals to 6371 times 10 raised to power 3 meter. Okay, so we are looking for charge. So can I say Q is equals to ER square divided by K. So electric field is 150 times R is 6371 times 10 raised to power 3 whole square divided by K. So K is 9 times 10 raised to power 9. Solve this. You will get 6.77 times 10 raised to power 5 coulomb. This is your charge. Clear, guys? Fine. And something very important you need to focus. Direction is downward. Direction is downward. So the result should be negative. Result should be negative. Till here, guys? Clear? Okay, so till here our question number 9 is finished. So I will meet you soon with the next video. Till then, take care. Bye.